Hello, my dear students, and welcome to a gentle lesson here with the Pillow Professor. Before we begin, I'd love for you to subscribe to the channel and give this video a like if you enjoy drifting off while learning something new. And if you hear any facts tonight that surprise you, leave me a comment and let me know what you discovered. Now get comfy, settle under your blanket, and let's explore tonight's cozy topic, our sun. The sun, that bright, blazing ball in our sky, is a star. It might feel unique because it's so close, but it's one of roughly 200 billion stars in our galaxy alone. The sun sits about 150 million kilometers away from Earth, a distance known as an astronomical unit. Though that sounds incredibly far, it's close enough for sunlight to reach us in just 8 minutes and 20 seconds. That same light fuels life on Earth, warms our oceans, and helps plants grow. Our sun is mostly made of hydrogen and helium, about 74% hydrogen and 24% helium to be more precise. Deep in its core, hydrogen atoms smash together under immense pressure and heat, fusing into helium and releasing enormous amounts of energy. This process is called nuclear fusion, and it's what makes the sun shine so brightly. Without this constant fusion, our world would be a cold, dark place. If we could peel back the layers of the sun, we'd see several distinct zones. At the center is the core, where temperatures soar to around 15 million degrees Celsius. Moving outward, there's the radiative zone, where energy slowly travels outward, sometimes taking thousands of years to escape. Then comes the convective zone, where hot plasma rises and cooler material sinks in swirling currents. Above all that is the photosphere, the part we see shining in the sky. And further out we find the corona, a wispy, glowing aura visible during solar eclipses. Our sun is enormous. You could fit about 1.3 million Earths inside it. In terms of mass, it makes up more than 99% of all the matter in our solar system. Its gravity keeps planets, comets, and asteroids orbiting around it. Even though it's massive, the sun is considered a medium-sized star when compared to other stars in the universe. Like all stars, the sun has a life cycle. Right now, it's in the middle of its life as a main sequence star. But in about 5 billion years it will run low on hydrogen and start to expand into a red giant. During that phase it will grow so large that it might engulf Mercury, Venus, and possibly even Earth. Eventually the outer layers will drift away, leaving behind a small, dense core called a white dwarf. Even then, traces of the sun's light will linger in the universe for billions of years to come. Throughout history, humans have looked to the sun with wonder and reverence. Many ancient cultures worship the sun as a powerful deity. The ancient Egyptians honored Ra, the sun god, believing he sailed across the sky each day and journeyed through the underworld at night. In ancient Greece, Helios was imagined driving a fiery chariot across the heavens. For the Aztecs in Central America, the sun was essential to life, and great temples were built in its honor. Even Stonehenge in England may have been constructed partly to track the sun's movements through the seasons. Beyond warmth and light, the sun affects our planet in many ways. Its magnetic activity creates solar winds, streams of charged particles that can travel across the solar system. When these particles reach Earth, they can cause beautiful displays of colored lights in the sky, known as auroras. The northern lights, or aurora borealis, dance across skies near the North Pole, while the southern lights, or aurora australis, glow in the southern hemisphere. But solar activity can also disrupt satellites, radio signals, and even power grids here on Earth. Our sun is not just a gentle companion, it can sometimes be a force to reckon with. The sun goes through regular cycles roughly every 11 years. During solar maximum, the sun has more sunspots, dark, cooler regions on its surface, and increased solar flares. These bursts of energy can send waves of radiation into space. During solar minimum, the sun is quieter, with fewer sunspots and less intense activity. Scientists study these cycles carefully because they can influence space weather and conditions here on Earth. When we look into the night sky, we see countless stars. Some are bigger, brighter and hotter than our sun. Others are cooler, smaller and dimmer. Massive stars burn hotter and live shorter lives, sometimes ending in colossal explosions called supernovae. Tiny red dwarf stars burn slowly and can live for trillions of years. Our sun, being a yellow dwarf, sits somewhere in the middle, an ordinary yet extraordinary star. Its steady glow has nurtured life on Earth for over 4.5 billion years. Without the sun, Earth would be a frozen world. Plants rely on sunlight for photosynthesis, turning solar energy into food and releasing oxygen into the air. Animals and humans depend on plants for nourishment and clean air. The sun also sets our biological clocks, helping us feel awake during the day and sleepy at night. Its gentle warmth and golden light have shaped cultures, calendars, and the rhythms of life for as long as humanity has existed. Even as we learn more about distant stars, our sun remains one of the most important and familiar objects in our sky. Though the sun appears yellow or white to our eyes, it actually emits light in all colours of the visible spectrum. When sunlight passes through Earth's atmosphere, shorter blue wavelengths scatter more easily, making our daytime sky look blue. At sunrise and sunset, the sun sits lower on the horizon, and its light travels through more of the atmosphere. This scatters away the blues and greens, leaving behind brilliant reds, oranges, and pinks. It's why sunrises and sunsets can look so breathtaking and soothing. Even though space is silent, scientists have found ways to listen to the sun. By studying vibrations on its surface, researchers can detect waves that travel through the sun's interior. This field of study is called helioseismology. These vibrations help scientists understand what's happening deep inside the sun, like temperature and movement patterns. If you could hear the sun, its vibrations would create a low, constant hum, a cosmic heartbeat echoing across space. Solar eclipses are one of the most dramatic sights connected to the sun. They happen when the moon passes directly between Earth and the sun, briefly blocking its light. During a total solar eclipse, day turns into an eerie twilight. Temperatures drop slightly, and stars can become visible in the sky. People have travelled great distances to witness this spectacle, feeling a mix of wonder and mystery as the sun disappears and re-emerges. Eclipses have inspired myths and legends for centuries, with some ancient cultures believing they were signs from the gods. Today, scientists use powerful telescopes and spacecraft to study the sun more closely than ever before. Observatories like the Solar and Heliospheric Observatory, or SOHO, keep a constant watch on solar activity. The Parker Solar Probe is even flying closer to the sun than any spacecraft has ever dared, collecting data about its outer atmosphere. By studying the sun, we learn more about our solar system, space weather, and how to protect technology and astronauts from solar storms. The sun remains both familiar and full of secrets waiting to be uncovered. It's comforting to know that the atoms making up your body were once created in stars like the sun. Elements heavier than hydrogen and helium, like carbon, oxygen, and iron, are formed inside stars or during their explosive deaths. So, in a way, we're all connected to the stars. The sun is part of that cosmic story, shining its light on our world and reminding us that we are truly children of the universe. For centuries, humans have relied on the sun to measure time. Before clocks existed, people used sundials, where a simple stick or object cast a shadow on a marked surface. As the sun moved across the sky, the shadow shifted, helping people track the passing hours. Our very concept of a day comes from the time it takes Earth to rotate once in the sun's light. Even today, our calendars and time zones are tied to the sun's journey across our skies. The sun has always been our most natural timekeeper. The tilt of Earth's axis is what gives us our seasons. As our planet orbits the sun, sometimes one hemisphere leans closer, receiving more direct sunlight and warmth. That's summer. When it tilts away, the sunlight is weaker and more spread out, bringing cooler temperatures. That's winter. The changing angle of sunlight shapes everything from blooming flowers to migration patterns in animals. It's amazing how much life on Earth dances to the rhythm set by our sun. The sun has inspired countless works of art, music, and literature. Painters have tried to capture its golden glow on canvas, while poets have written verses celebrating its warmth and light. From sun symbols carved into ancient stones to modern songs about sunny days, the sun shines brightly in human creativity. It's a symbol of hope, renewal, and the passage of time. No matter where people live, the sun remains a powerful presence in our hearts and imaginations. While the sun's rays bring warmth and life, they also emit ultraviolet, or UV radiation. Too much exposure to UV rays can damage our skin and eyes, leading to sunburns and increasing the risk of skin cancer. That's why it's important to wear sunscreen, protective clothing, and sunglasses when spending time in the sun. Earth's atmosphere, especially the ozone layer, helps shield us from some of this harmful radiation. It's another way our planet works hand in hand with the sun to sustain life safely. Even with all we know, the sun still holds mysteries. Scientists continue to study why the corona, its outer atmosphere, is much hotter than the sun's surface. They're searching for clues about how solar winds are accelerated and how magnetic storms form and travel through space. Each new discovery helps us understand not only our sun, but stars throughout the universe. And though the sun is an ordinary star in cosmic terms, for us, it will always be extraordinary. A glowing anchor in the vastness of space. Beyond its natural warmth and light, the sun offers us an incredible source of clean energy. Solar panels made of special materials capture sunlight and convert it into electricity. This technology helps power homes, businesses, and even spacecraft. Solar energy doesn't produce pollution or greenhouse gases, making it kinder to our planet. As technology improves, more people around the world are turning to the sun for sustainable power. It's fascinating to think that the same star that warms your skin can also light your home. The sun's gravity is the invisible thread holding our solar system together. It keeps the planets, asteroids, and comets in their orbits. Without the sun's gravitational pull, Earth would drift off into the cold darkness of space. Even distant objects like the icy bodies in the Kuiper Belt feel the sun's influence, though very faintly. Our solar system is like a cosmic dance choreographed by the sun's powerful gravity. The sun is also a key player in shaping Earth's climate and weather. Its energy heats the land, oceans, and atmosphere unevenly, creating winds, ocean currents, and weather patterns. During periods of high solar activity, subtle changes can influence Earth's climate, though human activities have a much stronger effect today. From gentle breezes to powerful storms, so much of our weather begins with the warmth of the sun. Our sun is just one star among billions in the Milky Way galaxy. It sits in one of the spiral arms, about 2/3 of the way from the center. As the Milky Way rotates, our sun orbits the galactic center, taking roughly 230 million years to complete a single trip. Astronomers sometimes call this journey a cosmic year. Right now, our sun is calmly drifting through a region of space known as the local interstellar cloud. Though the sun feels stable and familiar, it's always on the move through the galaxy. From time to time, dark spots appear on the sun's surface. These are called sunspots, and they're cooler areas caused by intense magnetic activity. Even though they look dark, sunspots are still incredibly bright. They just appear dimmer compared to the blazing surface around them. Sunspots often come in groups and can last for days, weeks, or even months. When the sun has lots of sunspots, it's a sign of heightened solar activity, which can lead to solar flares and powerful bursts of energy shooting into space. Sometimes the sun releases sudden, intense flashes of energy called solar flares. These flares can send streams of charged particles hurtling into space at astonishing speeds. Even more dramatic are coronal mass ejections, or CMEs. These massive clouds of plasma and magnetic fields can travel millions of kilometers per hour. If they reach Earth, they can disturb satellites, radio communications, and power grids. Despite their power, these solar events also help create spectacular auroras near Earth's poles. The sun isn't just a beautiful sight, it's also vital for our health. When sunlight touches your skin, your body starts producing vitamin D, an essential nutrient for strong bones, immune function, and overall well-being. However, it's important to balance time in the sun to avoid overexposure. Even brief moments in gentle sunlight can help keep your body healthy and in balance. It's another quiet way the sun looks after us each day. While Earth experiences seasons because of its tilt and orbit around the sun, other planets have their own unique seasonal rhythms. Mars, for example, also has a tilted axis, creating spring, summer, autumn, and winter, but each season lasts about twice as long as Earth's. On Uranus, the planet's extreme tilt means each pole has 42 years of sunlight, followed by 42 years of darkness. All of these variations are tied to how those planets relate to our Sun. It's a reminder that while the Sun is the same star for every planet, its influence creates different experiences across the solar system. Scientists are always looking for new ways to learn about the Sun. Future missions will fly even closer to its surface, measuring temperatures, magnetic fields, and the origins of solar winds. Understanding the Sun helps protect technology on Earth, plan safe space travel, and unravel secrets about stars across the universe. Each discovery brings us closer to understanding how our star shapes life and connects us to the cosmos. Even as we learn more, the Sun remains a source of endless wonder, shining quietly at the heart of our solar system. About 4.6 billion years ago, our Sun began its life in a giant cloud of gas and dust. Gravity pulled parts of the cloud together, forming a dense core. As the core grew hotter and denser, nuclear fusion began, and the Sun started to shine. Leftover gas and dust around it slowly clumped together, forming planets, moons, and other objects in the solar system. In a way, we're all made from the same stardust that once surrounded the newborn Sun. Because the Sun is so close, it's a perfect example for astronomers to study. By watching how it works, its light, heat, and magnetic activity, scientists can learn about more distant stars. Observing the Sun helps us understand star formation, stellar life cycles, and the powerful forces shaping galaxies. It's like having a cosmic laboratory right in our backyard. Even the tiniest details we learn about our Sun can unlock secrets about the universe beyond. Although it looks perfectly round, the Sun isn't a solid ball. It's made of plasma, a hot, swirling soup of charged particles. Because of this, it spins faster at its equator than at its poles. At the equator, the Sun completes a rotation about every 25 days. Near the poles, it takes around 35 days. This difference in rotation speeds helps twist and tangle the Sun's magnetic fields, leading to sunspots, solar flares, and other solar phenomena. If you could see sunlight separated into all its colours, you'd notice a rainbow of hues. This band of colours is called a spectrum. Astronomers use special tools called spectrometers to study the sun's spectrum. Tiny dark lines in the spectrum reveal what elements are present in the sun's atmosphere. These clues help scientists determine the sun's composition and even its temperature. Each star has a unique spectral fingerprint, and our sun's is well studied and familiar. Long before compasses or GPS existed, sailors and travelers used the sun to find their way. By watching the sun's path across the sky, people could tell direction and even estimate the time of day. At midday in the northern hemisphere, the sun is usually in the southern part of the sky. Navigators would also measure the sun's angle above the horizon to calculate their latitude. Even today, some traditional sailing techniques still use the sun as a reliable guide. The sun has always been a silent companion on humanity's journeys. The sun plays a vital part in growing our food. Farmers plan planting and harvest times based on how much sunlight crops need. Different plants require different amounts of light for healthy growth. Long days of summer help fruits ripen, while shorter days signal the approach of harvest for grains and vegetables. Without the sun's light and warmth, fields would remain barren and food could not grow. Every meal we eat is a quiet gift from the sun's energy stored in plants. Around the world, countless stories have been told about the sun. In Japanese mythology, the sun goddess Amaterasu is said to rule over the heavens, bringing light and life. In Hindu traditions, Surya rides a golden chariot drawn by 7 horses, spreading light across the world. Native American cultures often tell tales of the sun as a powerful spirit watching over the earth. These stories reflect humanity's deep respect for the sun's warmth and light. For as long as people have gazed upward, the sun has inspired awe and wonder. Spacecraft exploring our solar system rely on the sun for power. Many missions, like those to Mars or the outer planets, use solar panels to collect sunlight and generate electricity. Even the International Space Station depends on solar arrays to power its systems and keep astronauts safe. Understanding the sun's behavior helps engineers protect spacecraft from solar storms. Our journeys into space always remain connected to the sun's glow. In places close to the poles, the sun's patterns create unique seasons of light and darkness. During summer in the Arctic or Antarctic, the sun can stay above the horizon for days, weeks, or even months. This phenomenon is called the midnight sun, where daylight lingers at all hours. In winter, the opposite occurs, bringing long stretches of darkness known as polar night. These shifting patterns of sunlight shape life in these regions, from migrating animals to human traditions and festivals. The sun's path in the sky changes everything from mood to survival in these faraway places. All around the world, scientists have built special observatories to watch the sun. These telescopes study the sun's surface, its magnetic fields, and bursts of solar energy. Some observatories use filters to safely observe the sun's different wavelengths of light, revealing hidden features invisible to the human eye. The Daniel K. Inouye Solar Telescope in Hawaii is one of the most powerful solar telescopes ever built, helping scientists see tiny details on the sun's surface. These observatories help keep watch over our star, learning its secrets day by day. Sunlight isn't just warm and bright, it also carries a tiny push of force called radiation pressure. Scientists have created lightweight spacecraft called solar sails that catch this gentle push like a sailboat catches the wind. Over time, the constant pressure of sunlight can propel these spacecraft across the solar system without using fuel. The Japanese spacecraft Ikaros was the first to successfully fly using a solar sail. It's a beautiful idea, traveling through space, powered only by the light of our sun. Earth has a magnetic field that protects us from the sun's charged particles. When bursts of solar energy hit this magnetic shield, they can create beautiful auroras near the poles, but strong solar storms can sometimes disturb technology, including satellites and power grids. Scientists monitor the sun closely so they can warn us if a big solar storm is on the way. It's another reminder of how closely Earth and the sun are linked in a delicate cosmic dance. Throughout human history, the sun has been a symbol of hope, renewal, and new beginnings. It rises after the darkest night, reminding us that light always returns. It marks the passage of days, seasons, and years, weaving a gentle rhythm into our lives. Even in moments of hardship, many people find comfort in the sun's simple presence. Its steady warmth and glow whisper that life continues, and new days always come. As we learn more about the sun, our connection to it grows deeper, blending science with wonder and gratitude. Animals, just like humans, rely on the sun in many ways. Birds often use the position of the sun in the sky to help them navigate during long migrations. Some insects, like bees, use sunlight and patterns of polarized light to find their way back to their hives. Many animals have internal clocks, called circadian rhythms, that are set by the cycle of sunlight and darkness. These rhythms guide sleeping, feeding, and even breeding behaviors. The sun quietly orchestrates the daily routines of life all across the planet. Long ago, people carefully watched the sun's path to mark time and seasons. Many ancient calendars were based on the sun's movements across the sky. The ancient Egyptians created a solar calendar with 365 days, closely linked to the annual rise of the Nile River. The Mayans tracked solar cycles with remarkable precision, building temples aligned to the sun's position on certain days. Even modern holidays often trace their timing back to solar events like solstices and equinoxes. Our connection to the sun's rhythm runs deep in human history. Sometimes the sun creates beautiful optical effects in the sky. A solar halo appears as a glowing ring around the sun, formed when sunlight passes through ice crystals high in the atmosphere. Sundogs, or parhelia, are bright spots that appear on either side of the sun, often shimmering with rainbow colours. These phenomena remind us that the sun's light can paint delicate and fleeting art in the sky. Next time you see a ring or bright spots around the sun, you're witnessing one of nature's quiet wonders. One of the sun's greatest gifts is photosynthesis. This is the process plants use to turn sunlight, water, and carbon dioxide into food and oxygen. Tiny structures in plant leaves called chloroplasts capture sunlight and transform it into energy. Without photosynthesis, there would be no food chains, no oxygen for animals to breathe, and no forests or fields swaying in the breeze. Every breath we take carries a trace of sunlight, transformed by green leaves. The sun sends out many kinds of light, including invisible ultraviolet rays. Some ultraviolet light helps our bodies produce vitamin D, which is good for bones and health. But too much UV light can harm skin cells, causing sunburn or increasing the risk of skin cancer. That's why we wear sunscreen, hats, and sunglasses to protect ourselves from the sun's hidden power. Even in its gentlest glow, the sun reminds us to respect its energy. Scientists talk about something called the solar constant. It's the average amount of solar energy that reaches each square meter of Earth's outer atmosphere every second. The number is about 1,361 watts per square meter. This steady stream of energy powers our weather, our climate, and life itself. Though the sun's output varies slightly over time, it remains remarkably consistent, a dependable presence in the sky. And so, my dear students, we come to the end of tonight's gentle journey together. I hope you feel a little closer to our sun, and perhaps a little more connected to the great glowing story that unfolds above us each day. If you enjoyed drifting through these sunlit facts, please remember to subscribe to the channel, give this video a like, and share it with anyone who might love learning while they relax. And if there were any new facts that surprised you tonight, I'd love to hear about them in the comments below. Until our next lesson, may your dreams be warm and bright, and may the gentle light of knowledge guide you always. Good night, my wonderful students.